As I sit here and stare at these massive freight cars I'm building, I remember back one day when I was at Horseshoe Curve and we were with a friend. He said, "Yeah, the engine is 10 times better than the brake." And that got me thinking, why don't you just take all the energy from this when you're going downhill and braking and convert it into energy and store it in the engine? Because how it works is you have a dynamic braking system, basically a bank of resistors, and like a toaster hooked to a bicycle generator and you can't pedal, it has the same kind of braking effect for the traction motors in the engine. So basically, the engine switches its motors into a generator and sticks all that power into a bank of resistors with like different notches to slow the train. And basically, it takes all the energy, dumps it right in the resistors, and turns it directly into heat. It's like, why don't you just kind of figure out a way to store it? I mean, if you go and watch the video where I have these 10 volt, 100,000 microfarad capacitors and they keep an LED lit for about 40 hours, that's kind of where I think they should be looking. I tell you what, if you could put some kind of generator on almost each wheel of these, not like one big one, but like tiny ones, or the whole thing and somehow store it, I think you could power the train uphill. I mean, well, it only makes sense. I mean, geez, if you're going downhill and you have to stop to slow the train so it doesn't around a curve, why don't you turn all that into energy and dump it back in the engine? So you get to the hill and you go up the engine with like no trouble. I mean, it only makes more sense that way. I mean, if the engine is 10 times stronger than the brake, then why don't you do something like that? And while we're on braking, everyone thinks, oh, you need air pressure to stop. No, it's actually in reverse. You need air pressure to release the brakes. Because if it was in vice versa and you had an air leak, it's not going to stop the train. So basically, if you lose air, it locks the brakes on. Basically, you add air, it pushes the piston, for an example, and it releases the brake from the wheel. I mean, you just would not do that in reverse. Alright, I think we talked enough here.